Okay, this one will be short, much shorter than the last one. So systems of equations and inequalities. So with equations, you're gonna have three variables, right? Some number times x plus some number times y plus some number times z equals a number, right? One of these could be 0. You may not actually have that term. But you're looking for your totals and your comparisons. You're letting your variables equal whatever, and then you're writing out the actual equations, right? With inequalities, you're just gonna have two variables, right? Greater than, less than, greater than or equal to, less than or equal to some number. Okay, so you're looking at your totals, right? With the keywords that go with them to help you figure out which inequality symbol to use. You're listing out your variables, and then you're writing the actual inequality statements, okay? The important thing that gets a lot of people is the comparisons, right? So if I said you had 4 more quarters than nickels, people don't know what to put the 4 with. You're always going to put the number that it gives you with the second letter, the second variable, okay? So quarters would equal n plus 4. Because if you have 4 more quarters than nickels, then quarters does not actually equal nickels, right? Because you have 4 more of these. So in order to make quarters equal the same amount of nickels, then you had to add 4 to the number of nickels so that it would have as many quarters. Have as many as quarters does, right? When you're graphing systems of inequalities, okay, you are going to Desmos.com. If it gives you something like this, you are going to Desmos.com, okay, and you are typing these in because it will automatically shade and graph them for you. And what you're doing is you're looking for where the shaded areas overlap, okay? So if you're trying to figure out which ones are solutions, then you're looking for the solutions where the two shaded parts overlap each other, right? If you're looking for points that are not in the solution set, then you're looking for points that don't lie where the overlaps hit. It could be in the shaded part, but not where the shaded overlaps, where the two shaded parts overlap each other, right? One last thing that you will see come up is something similar to this. We went over this already, right? When you have your ones on diagonals and the rest are zeros, it's going to give you your answer, some number for your x, y, and your z, right? Or in this case, they say a, b, and c. You have one solution, one number for x, one number for y, one number for z, okay? What we didn't really talk about yet is if you have two diagonal ones and then it's just zeros right here, but you get an a, b, and a c, like a number right here, it's no solution. Okay, it didn't get that final diagonal to create a solution. Infinitely many is just zeros all the way across. So it's kind of like saying 0 is equal to 0 kind of thing. You have infinitely many solutions. Okay.